more than 30 times farther from the Sun, near the outermost edge of our solar system, drifts a world so remote and mysterious that even the most powerful telescopes struggle to decode its secrets. A planet wrapped in blue mystery, hiding storms that dwarf Earth's hurricanes, rings that flicker in and out of visibility, and perhaps buried oceans of searing hot water. This is Neptune, the least explored and perhaps the strangest of all the planets in our solar neighborhood. But how can a planet so far from the warmth of our Sun possibly contain oceans of heat? And why does it glow a deeper blue than any other planet? Stick with us as we unravel the shocking truths about Neptune's violent winds, its ghost-like rings, and its bizarre star-like moon that may harbor an alien ocean beneath its icy crust. If you're fascinated by space's coldest corners and the secrets they keep, you're in the right place. This is Curiosity Echo, and today we're diving into the abyss of Neptune. Before we dive deeper, don't forget to subscribe to Curiosity Echo, ring the bell, and like the video. Every click helps us continue exploring the universe one mystery at a time. Neptune sits at a staggering 2.8 billion miles from the Sun. That's so far, light itself takes over 4 hours to reach it. At that distance, Neptune receives just 0.1% of the sunlight that Earth does, making it a frozen world in every sense. Or is it? Here's the twist. Beneath Neptune's icy clouds, scientists believe there could be oceans of superheated water. That's right, scalding water, under crushing pressure, trapped below layers of ammonia and methane ice. This isn't your typical ocean. It's a bizarre, high-pressure plasma sea that may exist near the planet's rocky core. But how can something so hot exist on a planet that's colder than dry ice? The answer may lie in Neptune's core itself. Like Earth, Neptune generates internal heat, but it goes much further. In fact, Neptune emits nearly 3 times more energy than it receives from the Sun. No one knows why. Could it be from a colossal ancient collision? Could tidal forces with its bizarre moon Triton be at play? Or is it something else entirely? A new, undiscovered planetary phenomenon? Let us know what you think. What's your theory for Neptune's internal furnace? Drop your ideas in the comments below. Neptune's atmosphere is a dense soup of hydrogen, helium, and about 1% methane. It's this methane that gives Neptune its iconic rich blue hue, far deeper than Uranus, which contains similar gases. But why the difference in color? Dr. Patrick Irwin of Oxford University believes the answer lies in Neptune's atmospheric layers. Methane, fog, and haze interact with sunlight in ways that amplify Neptune's blueness. The planet's hyperactive weather system thins out some of these haze layers, allowing deeper, bluer light to reflect back into space. And what a weather system it is. Neptune is the windiest planet in the solar system. Its winds rage at speeds of up to 1,200 miles per hour, faster than a speeding bullet. These gales twist and churn in a planet that spins once every 16 hours, whipping the atmosphere into dark storms that rival anything seen on Jupiter. In fact, Neptune has its own version of the Great Red Spot. Scientists call it the Great Dark Spot. This Earth-sized storm was first spotted by Voyager 2 in 1989, only to mysteriously vanish years later, then reappear again in 2018 in the planet's northern hemisphere. These violent vortexes seem to appear and dissolve in cycles that last just a few years, a stark contrast to Jupiter's centuries-old tempest. But one storm in particular caught scientists off guard. In 2019, a massive dark spot began migrating south, then suddenly reversed course. Even more mysteriously, it appeared to shed a smaller vortex like a budding cell. This kind of atmospheric behavior has never been seen on any other planet. And speaking of the unseen, Neptune's rings are among the most elusive features in our solar system. For decades, they were invisible, until Voyager 2 and later the James Webb Space Telescope captured faint glimmers of them. Neptune's rings are not like Saturn's grand displays. They are thin, dusty, and mysterious. There are 5 primary rings, each named after astronomers who studied Neptune. The innermost, Gal, is loose and dusty. The brighter Leverrier ring is narrow and denser. The Lassell ring spans over 2,400 miles in width. Then there's the faint Arago ring, and finally the Adams ring, home to perhaps the oddest structures of all, arcs. These arcs are bright clumps of dust, defying the laws of motion. They remain clustered instead of dispersing. Each arc has a name: courage, freedom, equality, and brotherhood. These are not poetic names. They mark real physical features that are shifting, exchanging material, and puzzling scientists. What holds them together? No one knows for sure. Could it be shepherd moons? Or remnants of a destroyed moon? Maybe even evidence of a recent gravitational disturbance. The truth is still out there, waiting. Beyond the rings lies Neptune's most intriguing companion, Triton. At first glance, it looks like a star in the night sky. In fact, it reflects 70% of sunlight due to a crust of nitrogen ice, making it even brighter than the planet it orbits. But Triton is no ordinary moon. It moves in retrograde, meaning it orbits Neptune in the opposite direction of the planet's rotation. This is almost unheard of and hints at a violent past. Most likely, Triton didn't form around Neptune at all. Scientists believe it originated in the Kuiper Belt, a distant region full of icy objects. At some point, Neptune's gravity snagged Triton, pulling it into orbit and possibly demolishing any moons that existed before. This explains why Neptune has so few moons, just 14, compared to Jupiter's nearly 80. Triton is larger than Pluto and is the only large moon in the solar system with a retrograde orbit. But it's what lies beneath its icy shell that captivates scientists. Voyager 2 image showed dark streaks and geyser-like plumes, evidence of cryovolcanism or ice volcanoes. These eruptions may suggest that Triton hides a subsurface ocean, kept warm by tidal heating or the antifreeze effect of ammonia. Could Triton be another ocean world like Europa or Enceladus? Possibly, and with an atmosphere, albeit a thin one, made mostly of nitrogen, Triton's landscape resembles an alien Arctic more than a dead moon. Think about it, a captured world, potentially harboring water, covered in ice and bursting with geysers. If that doesn't scream, investigate me, what does? And what of Neptune's Auroachtos origin story? It may not have always lived in the outer reaches of the solar system. Many scientists now believe Neptune formed closer to the Sun before migrating outward. This idea is supported by its gravitational resonance with Kuiper Belt objects like Pluto. These objects are locked in orbital patterns dictated by Neptune's invisible hand. Without Neptune, many of these icy bodies would likely have been flung into interstellar space. In this way, Neptune acts as a kind of cosmic shepherd, not just of dust rings, but of dwarf planets and icy relics from the birth of the solar system. So let's bring it full circle. A frozen blue world with hurricane-force winds, rings that defy physics, a moon that glows like a star and may hide a warm ocean beneath its surface, and an origin story that suggests it didn't even belong here to begin with. Neptune may be cold, but it's anything but lifeless. In fact, it may hold answers to some of our most profound cosmic questions, from how planets form to how they migrate, to whether life could exist on ice-covered moons in the farthest reaches of our solar system. So what do you think? Should Neptune be our next planetary mission target? Would you like to see a dedicated probe sent there? Let us know in the comments. And don't forget to like this video, subscribe to Curiosity Echo, and turn on notifications so you never miss a dive into the universe's deepest secrets. Thanks for watching. Until next time, stay curious.